Hey all, so welcome to the week 4 lab on enzymes. It actually seems shorter this week, doesn't it? I guess because it doesn't have a huge title like they seem to always have. So that makes it nice. But anyway, so you read your lab, do the lab, turn in the lab document, make sure everything's in that document, submit via the assignments tab. You won't see this. You'll get to your lab document, which is much better formatted, and the rubric and the playlist. So let's go hit that rubric first. So we're back to having observations. We've got 3 exercises. Oh, I didn't change this part. Hopefully you won't see that part. We'll go save. Used to be different with the lab summary. And I will make a note of that. Which one is this? Week 4 enzymes. Week 4 enzymes. I need to upload a new rubric. Most of them are the same, right? But some of them have changed. All of the labs have changed because I updated everything. Okay, rubric, and then it's going to be 0.75 for complete sentences, grammar, and the lab summary, which is now a separate thing. And not, it was weird before. It was really weird. Okay, so this one's not so bad because you're doing like 3 different things, so it's very similar, but let's go look at that lab. So, create the title page, title, your name, course number, date, my name, optional. Okay. And then we have the lab. So our observations, it says see the next page because there hecka wasn't enough room. And this made everything fit on one page. I was much happier. So you're going to use plus plus if it's blue, black or blue, so starch is present. Only 1 plus if it's light blue or light blue black. So some starch, and amber orange is going to be a dash, right? So you should have, typically everything's going to start with a double plus and then change at different times, right? You should have something in here that changes to a negative and something that stays as a double plus, and then something in here that finally changes, right? You look at temperatures, we're guessing that 37 is probably going to do really well, 0 is probably going to be a little slower, and 100 seems like that might hurt your enzyme. So then same thing here. You're going to have to put in your percents though, so make sure you do that. And then it's probably going to start double plus and then fade out, right? And then one might take the whole time. And then the next one, let's look at it. So probably start at double plus, and then probably it looks like 2 will disappear quickly and 2 will never disappear. So you will have to figure that out. I'm not telling you which 2. Oh, and make sure you put your pHs in here. And so then we do, first we're going to look at enzymes and temperature. So temperature is probably going to be our variable. So which color indicated that the starch was still present? Which color said no longer? When the starch disappeared as the color changed, what actually happened to it? So it didn't just go away. What happened? Why is there no more starch? What's the variable? What does the title tell us it might be? What's the control? And then you look at what the temperatures mean in Fahrenheit, and that will help you, which you'll do later down here anyways. Based on the results of table 1, which temperature is optimal for the enzyme? Make sure I'm telling you the truth when I say that. See? What? Yes. I was saying the truth. So then what temperature facilitated the conversion first, second, and third? Or did any other, not actually do any? Why or why not? So it's probably going to be the 0, the 100. 0, maybe it's frozen, I don't know. 100, maybe, why would it not work? What happens to this stuff when you boil it? The 37 is mid-range, so in degrees F, what's 37? Why would we care? And why is it important to immediately observe the color of the stuff? Why didn't you add the indicator directly to the test tubes? Why might that be bad? Blah, blah, blah. I can talk. Why might that be bad? What happened when you incubated the test tubes? It still can change it. So like 37 is already done, so now you're talking about 0 and 100. So what happened to the 0 and the 100? Did they finally have a disappearance? Which one probably didn't? What happened after since you're incubating, you're probably making one warmer, so I'd guess it's in the one you made warmer that stuff happened. What happened when you added extra into the G that still wasn't doing anything? So So you have one dude that's not doing anything, and suddenly you have a new enzyme. That's not whatever happened to it before. So why would that make a difference? And then we construct a graph. Let me look and see what their graph looks like. I told you, yeah. So your x-axis is going to have your time from 0 to 100, and then you just have test tube 1 as a bar for it at 0, test tube 2 a bar for it at 37, and test tube 3 a bar for 100. You know, the relative concentration, blah, 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 plus is the highest, yeah. And then do concentrations, or you can do something else. You figure it out. As long as, typically a bar graph's easier. Just make sure the big thing is time on the bottom, concentration on the side. Okay? Then we do the discussion. So was it refuted? What have you learned about temperature and the enzymes? And then what's the practical application? So practical means, to me, like if you're going to do this to make money in the real world, so like as a factory or in medicine, how would this help? So not just like in your own personal house. We want like a real world example. So think real world. So now we're doing enzymes and substrate concentration. So what do you think we're going to be looking for? So what's the variable? The concentration of what? What? Actually, ACE. So, yep. And then what is your test tube with the most, the least? How could you improve this? Construct a graph. It's going to be the time on the bottom, test tubes on the side. Then we do, the next one is our hypothesis. Supported or refuted. Remember, you never prove, you only support or refute. What have you learned about concentrations and enzyme? So you changed the concentration of the enzyme, right? And that did what? So is that important? And then what was the practical knowledge, again, in medicine or in a business, real world, think real world. Describe another way to do this experiment with the same concept. So here you changed your concentration of what? So what could you try changing concentrations of instead? So enzymes and pH, now pH is going to be the thing we move around. So what's the variable? In which test tubes did you see conversion happening? And why might you expect this? What's a high pH? What's a low pH? Is one acidic? Is one basic? Is one like the body? And which ones did not show it? And why? Did the reasons, blah, blah, blah. Did the results support or refute? What were the conditions that made the actions, that might affect the action? So you're looking at pH, so why might those affect your actions? Where am I? I don't know where I am. Blah, blah, blah. I just did that. I just did the results. And then we just said, how might you propose to test this? What have you learned from this experiment? And then what practical applications might this knowledge have, right? So very similar to the last ones. I'm just like losing my mind. Oh, there we go. Yeah. All right. So that's going to be all for this experiment. Then we're going to change it to the laboratory summary. Blah, blah. So back to having 3 sentences, and then you add your reference section if you need it. Yeah, this was all like really weird before, so not all of it's in the answer key the way it is. But I know what it is. When I read it, I will be fine. So the big thing here is we're going to test those things. Really read your exercise titles because it knows it helps you know what you're focusing on, and that just kind of clarifies things. I mean, they tend not to lie. And then you're looking at what you're doing. What are you changing? If you're changing one certain, thing, that's your variable because it's varying across whatever you're doing. And then always compare things to like your human body, or if it's super acidic or whatever. And apparently it is time to do beard stretches if you are a bearded dragon, because he's over there having a great time. Maybe I'll try to feed him some lovely insects today. Okay, focusing. which is hilarious because I seem flare up and flare down, flare up and flare down. Distractions are good while you're doing this stuff, a little bit of distractions, right? The lab stuff needs to be very precise, but sometimes when you're reporting, give yourself a break. I like to do things like writing a lab report and all stuff while I'm doing laundry because it gives me a nice forced break to have that mental change up so I'm not so tired. Okay, anyways, as always, send me a review if you can, or draft so I can review it by noon on the due day. Okay, bye.